Hi there, welcome back to another Study With Me session. My name is Amy. I'm the head maths tutor at Pinnacle Coaching College. So today what I've got for you is factors. So the factors component of the syllabus, I'll break it into two videos. This is part of the new syllabus for the Extension 1 course in mathematics in New South Wales. And I know assessment is just around the corner, so hopefully these videos are going to help you just in time if you're getting examined on factors in this term. All right, let's get straight into it. I'll just move these. Okay, so I think those of you who do physics will have a very good understanding of factors, or at least I hope you do, because that's sort of the bread and butter of physics. But even if you don't do physics, right, understanding factors and what it is just about knowing what to do with them and knowing the rules around manipulating factors. But what exactly is a factor? Basically, for those who are not doing physics, it's literally an arrow, right? So it's literally just an arrow. And what that little arrow is supposed to represent here is magnitude and direction. So sort of some notation here. This is the tail end of the factor, and this is the head end. The arrowhead is the head end of the factor. What represents magnitude? It's basically the length of this thing, and sort of direction is sort of the angle or wherever it's pointing basically. So you would sort of hear me mention these terminology, magnitude, direction. So before we sort of dive into that, let's just talk about some very basic concepts around scalar versus vector quantity, because we'll be looking at quite a few of that, those kind of concepts as we work through factors. Scalar quantity, without getting too sciencey and complicated about this, it's usually just magnitude. Let me give you an example. If I said I am 30 meters from wherever, actually, let's just say 30 meters, because once I say from wherever, I start getting into a vector quantity. Okay, so magnitude 30 meters, that's it. Okay, whereas a vector quantity is magnitude plus direction. So example of that will be I am currently 30 meters north of where I've started or something like that. Yeah. Another very common concept, speed versus velocity. Speed might be just 30 meters per second. So that's just literally how quickly you're moving. But I don't know whether you're going forwards or backwards, right? Whereas velocity, it could be 30 meters per second backwards. And now I know, oh, you're not actually moving forwards. All right, so that's the major difference. I think for our purposes, that's all you really need to know. And as I mentioned before, a vector is just an arrow where the length represents the magnitude. So sometimes you will see these notations. So that's just vector A. So in terms of notations, yeah, vector AB, so from A pointing towards B, yeah, that's how you read it, or in this case, just simply represented by vector A. All right, so let's say, for example, might do a new page so I'm not so cramped up here. Okay, so let's say, for example, I have a vector. So let's say this is north, east. Okay, so I'll say vector OA is a vector. So remember, magnitude and direction. So let's say it's 10 kilometers. So it's a vector with 10 kilometers in magnitude and north 30 degrees east in direction. All right, so that's all we really mean. Okay, and just notation wise, if you See absolute brackets around a vector, that just means the magnitude of that vector. And in this case, it would have been 10. All right, so that's just some basic notation right there for you. All right, so moving on. So before we start manipulating vectors, you have to understand, well, how they operate, and when they're equal, how do you get the negative vector? So vectors are equal essentially if you imagine you have an arrow and then you keep copying and pasting, those are always equal, right? So what really we're after here is same magnitude and same direction. So for example, so I mean, my drawing is not the best. Probably slightly longer on that one. Okay, so let's say this is vector A, vector B, vector C. Yeah, they're pointing in the same direction, roughly the same length. So they are equal. Now, to get the negative vector, very simple, just flip the arrow. Alright, so let's say this is vector A. The negative vector is just flip the arrow. Alright, so you'll find that I do take a very non-sciencey, non-technical approach with vectors, because I think at the end of the day, like especially for those math students who are not going to apply this in physics, well, you just need to know enough to answer the questions well, right? So I'm just going to give you a very basic, simple, not so much basic, but a simple understanding that will let you do the work without, getting very sciencey about this. So hopefully this is helping you. All right, scalar multiplication. So what that is let's say this is vector A. What happens if I times 2 to it? Well, imagine taking this and then just stretching it double the length. Okay, so that's what I mean by scalar. If you multiply a number to it, you're just adjusting the length of the arrow without changing the direction. Unless, let's say, if I have minus a half, so the minus, remember, flips the direction. So the minus flips this to the opposite direction and I need a half the length. So it will be roughly like that. All right, so that just gives you a sense what happens when you multiply a number to a vector. All right, so basic rules around addition and subtraction of vectors. I'm going to teach you 2 rules. Both rules are important in their own right. They are used in different occasions and just helps you understand vector addition when you actually have a very complicated diagram. Okay, so the first one, the sort of core one, is the triangle rule. Very, very simple. So imagine taking this. Yeah, I'll see if I can actually just copy this. Let's see. Okay, so I can move this. All right, so imagine, okay, so I just copied the vector. All right, so addition rule, you migrate the other vector. That's roughly right, yep. So that was the original arrow. Yep. Okay, so you migrate the other vector so that the head of the previous vector is touching the tail of the next vector. First step. Second step, complete the triangle. So literally join it up so you form a triangle. Okay, then that's pretty much the addition vector. You just need to put in an arrow. So which way does that arrow point? Points towards the head. Okay, so basically imagine this is a chain, right? You can actually do more addition by just tacking head, tail, head, tail, head, tail. Imagine you're building a chain and then finally just join from tail to head pointing towards the head. That's your addition vector. I'll show you an example later, but at least in a nutshell, you're just adding 2 vectors, you're completing the triangle. That's your addition vector. Okay, think my computer is dying a little bit of lag there. All right, moving on. What if I want to subtract the factor? So this time, think about, well, how do you get the negative factor? Negative factor, you need to flip the direction of the arrow. Okay, so that's roughly it. Okay, and basically it's the previous rule. You add the head to the tail. Now, it doesn't matter whether you put the head to the tail or put this head to the tail. So just to show you, I will do it like this. So that's A, and then that's B, or minus B, I should say. Okay, and the addition factor, complete the triangle pointing towards the head of the chain, and that's your A minus B. All right, so I hope that makes sense to you. Addition factor, complete the triangle. Subtraction, just flip the one that's meant to be subtracted and then add it together, essentially. Now, I'll also teach you the parallelogram rule because, to be honest, as we see some examples later, you will find that the way we draw factors, it just quite often triggers of our parallelogram shape, and it's very good to know, well, firstly, how parallelogram rule works, and just be able to glance a diagram and say, ah, that's the addition factor, or that's the subtraction factor. All right, so very, very simple. First, you move them so that they're sort of together first, where the tails are touching. So I'll do that in red, since they are in red anyways. Okay, so that's A, that's B. And then literally you complete the parallelogram. Right, that's about right. Okay, so then the addition factor is that main diagonal drawn from the two tails pointing to the opposite corner. Okay, now if you think about it, so think about how addition factors work. So if you move this across here, that would have been the same factor. Remember, if they point in the same direction and are the same lines, they're the same factors. So that's basically the triangle rule. Okay, it's just now done in the form of a parallelogram. So that's A plus B. And then I'll do it in a different color. The other diagonal, it's basically the subtraction factor. So if it's pointing towards A, then that would be A minus B. Okay, so how do I pick up very quickly what subtract what? Is actually very simple. So just look at where the arrow points. So in this case, if it's pointing towards A, it's A minus B. If it's pointing towards B, it's B minus A. So wherever it's pointing, that's the factor that goes first. So that's essentially the parallelogram rule. All right, so let's take a look at some example. So let's say we want to add these four factors. So imagine what you're doing is building a daisy chain, right? You don't have to do it in order. You can go A plus C plus B plus D if you want. Yeah, it shouldn't matter which way you do it. So I'll just do it in order. So what you want to do is move that up there so that the tail and the head are attached to each other. So I'll show you. All right, so that's roughly A, and then I'm going to copy that. That's B. I'm going to run out of room here. Let's see. I won't draw C for too long. Okay, that's roughly it. And then D. Okay, so once you've created your daisy chain, so you connect the tail end to the head end. Sorry, I didn't have a ruler, so it doesn't look perfect, but you know what I mean. So that's your addition factor. All right, so this is basically it's not really a triangle anymore, but it's just more general addition. How do you add factors? Very simple. Head, tail, head, tail, head, tail, until you finish adding all the factors, and then finally join the tail all the way to the head. That's pretty much it. Okay. What if I want to do some subtraction? So the main thing I want to subtract is B and D. So what I'm going to do is sort of draw the negative vector first so we can visualize it. Yeah, remember negative vector is just flip the direction. Okay, then from there, you just kind of link it all together. So I'm going to just add that onto that. So I'm going to do it like this. That's minus B, and then you've got A. And then I'm going to add C. And then minus D, so it's like this. All right, and then you just do the same thing. Tail, connect to the head, pointing towards the head. That would be your A minus B plus C minus D. Yeah, so exactly the same idea. Wherever it's a subtraction, you just flip the direction of the arrow and just add your daisy chain together. All right, so I hope that makes sense to you now, and hopefully I know vectors can be a very confusing subject, especially those who don't do physics, and I hope, you know, through my simple explanation, you're sort of wrapping your head around what to do with these arrows, right? It's just, arrows. All right, so let's have a look at some examples. This one. We've got two vectors here, so A, B, B, C, they represent A and B. And we want to find DA. Okay, so D pointing towards A. So that's how you read that, right? It's pointing towards A. Okay, so first of all, because this is a parallelogram, so these two sides are exactly the same. So in other words, DA is actually the same vector as CB. So if it was pointing that way, basically, okay? Which means this is negative B. Does that make sense? So it's the negative vector of this one. AC, so let's join it up. Okay, so now I don't know if you can see this. This is the triangle rule addition vector. So if you go head tail, okay, so this is the chain, and then this is the lines of joining from the tail to the head. So this is an addition vector. So in vector speak, it looks like this. Okay, so AB plus BC. So AB is A, BC is B. That's it. Okay, so it's A plus B in other words. All right, C, BD. Now there's a lot of ways to think about this vector. All right, so you can think of it as this one plus this one. So let me just illustrate that to you. BC, CD, and BD is your addition factor. Yeah, everyone see that? So that's the triangle rule in action. Okay, so in other words, we can say that BD is BC plus CD. BC, you can see it represents B, and CD is the negative vector, so minus A. Yeah, same length, opposite direction. Does that make sense? So that's B minus A. All right, so that's a basic example just to get us thinking about all the different vectors and the placements. So let's show you an even harder question. This one. Okay, so what we've got here is A, B, C. So C is pointing that way. M is the midpoint. In the first instance, we want to find MB. So I'm just going to highlight it first. We want to find that thing. Okay, so first of all, I want you to notice that MB is half of the bigger vector CB. Okay, so that's the direction we're going to go. We have to find out what CB is first. Okay, so if you look at this, if you go A, okay, I'll draw it here, A plus B, and then you flip this arrow, right? Because you want head to tail. Flip this arrow. So that will be minus C, yeah? Then joining the tail to the head, this thing would be A plus B minus C. Does that make sense? So in other words, this vector here, so in other words, BC, it's A plus B minus C. Yes, this vector pointing towards C. Now, obviously, we didn't want to point in that direction. We want to point the opposite direction, but doesn't matter. Let's do an opposite direction first. So BM is half of that, right? Because M is the midpoint, so these two are equal in length. And then MB, which is what we're after, is the opposite direction, so you need to take the negative of that. That's basically it. All right, so how about MA? So MA is this guy over here. That's better. Okay, so MA is this guy over here. And you can see in this triangle here. See if you can see it. So I'm just going to replicate it. So A, B, M. So MB plus BA, yeah, triangle. That's the addition factor, right? Pointing towards the head. So in other words, MA is equals to MB plus BA. Okay, but what are they? Well, MB, we know what it is. It's this thing, okay? And BA, you can see that is just vector A, okay? So I'm just going to copy. All right, so plus A, basically. All right, so I'm just going to expand it out and try to squish it all in here. So that's a half A minus a half B plus a half C. So that's a half A minus B plus C. All right, and that's the last vector there. So you can see that a lot of these discussions is around, well, creating that condition for addition of vectors, right? Trying to look at what is the triangle I'm working with and then try to build it from there. Or this one was a little bit more advanced, so it was a free vector addition to try to get to that bottom vector there. All right, so that is pretty much it. I hope this all makes sense to you. So yeah, if you have any questions or comments, because I know this stuff is not exactly the easiest, and I am acutely aware that there aren't that many exam questions out there because it's the first year that you guys have to do this topic. I mean, feel free to email us or just go to our website. There's actually a lot more revision resources on our website. So last term, I've actually done a bunch of videos as well to help our students with the preliminary exam. And I know some of that may have spilled over into the first term of E12 as well. So I'm definitely sure you'll find that helpful. You can also Facebook us as well. And even just commenting in the video below. If there are specific topics, right, you want me to explain or you're feeling a little bit unsure about, yeah, just message us. There's so many ways to contact us, and my purpose here is just to help you. Let's get through the assessment and so we can go on a summer holiday. All right, bye for now.